What happened in 1852? There was one large surveying project, because we need to tell you that the surveyors have used trigonometry for centuries. So there was a large surveying project in 19th century which was called as Great Trigonometric Survey, and largest ever theodolites were built. And during this survey in 1852, the highest mountain in the world was discovered. So from a distance of 160 kilometers, from six different locations, the peak was observed. So in 1856, the peak was named after Sir George Everest, who had commissioned and first used these giant theodolites. And these theodolites are now on display in Museum of Survey of India (SOI) in Dehradun. So we'll talk about the trigonometry, how to find the height and distance of various objects without actually going to measure them. The height and distances, if you're standing here, if anybody is standing here and there is a minar or say a pole or any of this which can hold or stand 90 degree or vertical to the ground, then just by looking at and finding out your angle of elevation is the angle between the horizontal which you make with the horizontal earth and the eyes, you can say your face, how much you move, the eyes you move to see the peak. So this is the angle of elevation. We mark it like this. So this is the angle of elevation, and if you know the angle of elevation and the distance you are away from this object, you can easily find out through the line of sight the distance of this object from the ground, that is the height. So there are two things. One is your angle of elevation. If you are looking down, then also you are if you take horizontal to the ground, then you are looking down, and when looking down, this is the angle of depression. So we make it like this. And the most important thing is, if these two are parallels, this is a transversal, so this angle becomes equal to this angle. So whenever we are computing, we'll see in the example, the angle of depression will take like this, but for computation this angle will be used. So this is angle of depression. So we have two angles which are called as angle of elevation and angle of depression. So you see that if we are aware of the distance, we are aware of the distance from the point or the foot of that particular object or building or say something here, then just by knowing the elevation of our eyes or the depression, we can find out the height or the distance. This is we are going to see in various examples. And most often in this kind of scenario, see, these are our trigonometric ratios. Pandit Badri Prasad Har Har Bol. Okay. So when we are dealing with the perpendicular and base, and if this is the angle, so most often in the examples also we'll see tan of the angle will be taken. Why? Because this is perpendicular, this is base, and perpendicular base are coming in tan. So we will use the tan and the cot. These are most often used in these trigonometric applications we'll see in real scenarios. So here is a tower. Question 1 is, or example 1 is, there is a tower which is standing vertically on the ground. So this is vertically standing on the ground, and from the point on the ground, which is 15 meter away from the foot of the tower, the angle of elevation, that means this angle, is 60 degrees. Find the height of the tower. So if this is the height of the tower and you're looking from here, you are 15 meter away, so just use tan 60, that will give you this height. Say this is height, this is your base, this is your say perpendicular also. So perpendicular by base, I want to continue what we have discussed up till now. So perpendicular by base, that is the height, and by base is 15. And tan 60, we are aware that it is root 3. So that will be what? 15 into root 3. This is our height of the tower. Just by one expression, we are able to find out the height. This is the real life application of trigonometry. We have another question. There is an electrician and she wants to repair this faulty pole. Now, first we have to find out what will be the length of the ladder. If she wishes to be somewhere 1.3 meter, below from the top. So this is top, and this is given as 5. The distance is 5 meter. She wants to be 1.3 meter below the top so that she can take the repair work. So this distance will be what? 5 minus 1.3, that will be 3.7. Now this distance is known. This is not known. The angle is 60 degree which this ladder is making. So the question says we have to find out the length of the ladder and the distance, how far from the foot of the pole this needs to be placed. So now again, same stuff, 60 degree, this is known, this is your base. So perpendicular by base is what? Tan theta, tan theta. So tan 60 will be what? Tan 60 will be nothing but 3.7, that is perpendicular by base, that is this base, which is the distance of the foot of the pole from the foot of the ladder. So this is what? Say this is distance d. So d can be easily computed by 3.7 by tan 60, and tan 60 we know what is the value of tan 60. This is your tan 60, and you can easily find out the distance. Now how about this distance? Ladder. So you know that this hypotenuse we have to find out. You can easily find out. If you find out this distance, you can take the Pythagoras theorem and find out. But if you want to use the trigonometric ratios, you can take sine. Sine is what? Perpendicular by hypotenuse, that is 3.7 by, that is the length of the ladder. Sine 60, again we know the sine 60 is nothing but root 3 by 2. So 3.7 by BC, that is the length of the ladder, is BC will be 3.7 into 2 by root 3. We'll take the value of root 3 as given in the question. The length of the ladder will be 4.28, and as I discussed earlier, this cot 60 will be 1 by root 3. That will give you this answer. 2.14 is the distance of the ladder from the foot of the pole. Another question is, an observer is here, and this observer is 1.5 meter tall. Now it is away from the chimney. The angle of elevation of top of the chimney from her eyes, from here, is 45 degrees. What is the height of the chimney? So this is the complete height of the chimney from here to here. This is what? This is 1.5. Let us take it as h. So this will take directly the tan 45 because we know that this distance is 28.5. This is given 28.5 meter away from the chimney. So this is again 28.5. This one also parallel lines. So tan 45 will be what? Perpendicular by base, that is h by 28.5. Tan 45 is 1, so h will be 28.5. So this is 28.5. And this is again 1.5, so we have to add 28.5 plus by 1.5 so that we get the height of the chimney. So exactly same thing has been done. We have found out the height as 28.5, and we have added 1.5 the eye's height from the ground, and this makes the height of the chimney as 30 meters. We have a question. I will see the question here. Okay, there is a point, there is a building, and there is a flagstaff. If we see at the top of the building, the angle is 30 degrees. If you see at the top of the flagstaff, the angle becomes 45 degrees. So we have to find out the height of the flagstaff. The height of the building is given to us. This is 10 meter tall building. So let us see how we are going to find out. This is 10. Let us take this tan 30. Tan 30 will be perpendicular by base. So what will it be? Because it is given as 10. So tan 30 is 1 by root 3. This is 10 AP. AP means the base. So base will be 10 root 3. Now base is 10 root 3. Now let us come again to tan 45 degree. Tan 45 degree is what? This x, say this is x. This is 10. So x plus 10 by base. So we'll find out the tan 45. Tan 45 will be 10 plus x by 10 root 3. And tan 45 is nothing but 1. So we can find out the x, which will be 7.32 if we place the value of root 3 properly. Then we have another question that if you consider this to be a sun, and then we have to find out the ratio, this shadow. So at this point, the shadow of this building or this tower is 30 degree. If you move 40 meter, that is the difference of the distance is 40 meter if you move to this point. So this is 60 degree. Now let us take it as x. Let us take it as h. So the combination will be tan 60 will be h by x, and tan 30 will be h by 40 plus x. Right? H by x and h by 40 plus x. So we have two equations, two variables, we can easily find out. Tan 60 we know, tan 30 we know. So this is tan 60, AB by BC, that is h by x, h will be x root 3. Let us take tan 30 AD by DB and we'll place 1 by root 3, and this h by x plus 40. We'll put h equal to root 3x here. Let us place it. Root 3x, h is equal to root 3x. We'll now go again back to the second equation, and we can find easily that x is 20, root x is 20, which gives h as x root 3, that is 20 root 3. Now we have angle of depression of the top and bottom of an 8 meter tall building from the top of multi-storied building. So this is a building. This is a multi-story building. This is an 8 meter tall building. So the angle of depression of the top is 30 degree. The angle of depression of the bottom is 45 degree. Now we have to find the height of the multi-storied building and distance between two buildings. So this is 8 meter tall. This is again 8 meter. If you make a parallel line, this is 8 meter. So what this will be? Let us take it as h, and this has say d or x. Anything you can take. X we can take. Now these two are parallel lines. If this is 30, this is going to be 30. These are transversal. This is 45 degree. These two are parallel. So this 45, that means this is 45. So take this 1045. 1045 is what? 1. This will be h plus 8 by x. So x will be h plus 8. This is first equation. And what will be 1030? 1030 is what? H by again x. So we'll place one equation in another and let us see how to solve it. So this will be this 8 plus h, and this PD can be easily found out that PD is equal to AC. So this is 8 by root 3 minus 1. So if we solve it, we can get easily, the way I explained you can easily find out the distance also and the height of the building. Now another question is, from a point on the bridge, this is the bridge across a river, the angle of depression of the banks on opposite sides of the river are 30 degree and 40 degree, 45 degree. This is 30 degree, this is 30 degree, this is 45 degree, this is 45 degree. Let us take it as x, this is as y. So by this triangle, this is 45, this is 45. So let us take this triangle. 1045 is what? 1045 is this is given as 3 meter. 3 meter by y. So y becomes 3. So we got y. By this triangle, this triangle, tan 30 is what? Perpendicular base, so 3 by x. And we can get easily x equal to 3 by tan 30. Tan 30 we know. This is how we get. So this is how the equation becomes. One is exactly equal to 3, the other is like this, 3 root 3. And if you want to find out the distance between these two, means these two, AD and DB, that is x and y, has to be added. This becomes equal to 3 plus 3 root 3.